Now we shall go into each class one by one and we shall discuss what is about them. But before that I want to discuss one thing. See, now in class A, what is the total number of IP addresses present? That is one question. In class A, the total number of IP addresses present is 2 power 31. In class B, what is the total number of IP addresses present? It is 2 power 30. In class C, what is the total number of IP addresses present? 2 power 29. In class D, it is 2 power 28. That is the first thing you have to remember. So, one kind of question is, given any class, what is the total number of IP addresses present? Okay. And now I'll just explain by taking each class one by one about what is the range and all. Okay, so let me take about class A. So I'm talking about class A. Okay, now before going to any further, I want to discuss about how the IP address is represented. IP address can be represented in two ways. One is you can represent it as a 32-bit number, all zeros and ones, that is one way. And second thing is you can convert the entire 32 bits into a decimal number, that will be a very huge number, that is one way. And the third way is you could divide the entire IP address of 32 bits. See, we have IP address of 32 bits. Okay, so we can divide the entire IP address of 32 bits into 4 parts, right, of 8 bits each, 8 8 8 8, and convert these 8 bits into decimal number and then put a dot in the middle. That is called dotted decimal representation. So what is dotted decimal representation is, given the 32-bit number, I am going to divide it into 8 bits, 8 bits, 8 bits, 8 bits. They are called octets. We are going to get 4 octets and take each octet and encode it to decimal and take that decimal number and put the dots in the middle. That is also called as dotted decimal representation, which is the most popular representation. You could use any representation like binary number or decimal number, but then the most popular representation used practically is dotted decimal number system, right? Which means we are going to divide it into 8 bits and then we are going to put a dot. Now one interesting point is, one thing is for sure, given a IP address in binary, you could just see that if it is starting with 0, you can say that it is class A. If the binary number is starting with 10, you can say that it is class B. If it is starting with 110, class C, 1110, it is class D. That one you can directly say. But then given a number in dotted decimal number system, how could you find out what is the class to which IP address belongs to? In order to answer that question, it is easier if you take the first octet, first 8 bits, and examine the first bit, isn't it? Because the first octet contains the first bit. Now if it is starting with 0, then it is class A. And one more thing, interesting thing is, these are all called prefix codes. Prefix codes means class A starts with 0, class B starts with 10, class C starts with 110, and class D starts with 1110, and class E starts with 1111, right? So now if you take any prefix of previous class, let us say 0, that will not be a prefix of any of the others, right? Which means 0 will not be a valid prefix to any of the other classes. If you take 10, 10 will not be present as a prefix for any of the other classes. Similarly, 110 is also not, 1110 is also not. So it is easier to classify the IP addresses into classes this way. Let's talk about class A first. I am just examining class A here. Okay, so you know that class A contains class A is starting with 0 and there are 32 bits. I'll just erase it. I want to talk about class A. Okay, the first point is, number of IP addresses in class A is 2 power 31 IP addresses. Okay, and second point is, they have taken the 32 bits and they divided class A into 2 parts like this. The first bit is going to be 0 as it is, and how many bits are remaining? 7 bits are remaining, right? So they have taken 8 bits as network ID and 24 bits as host ID part, right? And now the first bit is already fixed as 0. Out of 8 bits, first bit is already fixed as 0. Then how many bits are remaining here? 7 bits. So with 7 bits, how many networks of class A are present? With 7 bits, 2 power 7, which is nothing but 128 networks of class A are present, right? And now if you take any network, how many IP addresses are present in one class? It is 2 power 24. 2 power 24 is 16 million. Therefore 16 million IP addresses are present per one network in class A. These two numbers are important, right? So theoretically there are 128 networks of class A, and in each network there are 16 million IP addresses, right? But then practically, let's see the numbers. Okay, now the next question is, if I have these 8 bits, what is the range? So 8 bits are this: 0 followed by 1, 2, 3, 4, 5, 6, 7, right? I'm talking about only the first octet. Why am I talking about only first octet is that is what contains the starting bits. If I know the starting bits, then I can know what is the class it belongs to. Therefore, I am not examining all the octets, I am examining only the first octet. So using the first octet, I want to see what is the range of numbers that can fall in first octet if the network actually belongs to class A, or if the IP address belongs to class A, right? So now 0 and all these 7 bits can be, the starting can be zeros, 0 0 0 0 0 0, right? Therefore the starting network is 0, starting number is 0, and next one is 0 0 0 0 0 0 0 1, therefore the next number is 1, right? And next one is 0 0 0 0 0 1 0, therefore the next number is 2, so on. The last number is 1 1 1 1 1 1 1, 7 ones. 7 ones is nothing but 127. Okay, so remember this: 1 1 is nothing but 1, 2 ones is nothing but 3, 3 ones is nothing but 7, which means if I have only ones, it is nothing but 2 power number of ones minus 1, isn't it? It is 7 because it is 2 power 3 minus 1. If I have n ones, then it is nothing but 2 power n minus 1. If I have 7 ones, it is nothing but 2 power 7 minus 1, which is nothing but 127. Therefore the number of networks are 0 to 127, which is nothing but 128, but we are not going to use 0 and 127. I'll explain you later why we are not going to use 0 and 127 practically. Therefore practically the number of networks present in class A is 126. Even though we got 128, we are not going to use 0 as a valid class A network and 127 as a valid class A network. Therefore even though we have 128 as theoretical number, practical number is going to be 126. So practically 126 networks of class A are present, and in each network we have 16 million IP addresses, right? So this is the range. So now the range of the class A is 1 to 126. Okay, so the range of class A is nothing but 1 to 126. So if you see any IP address in which the starting number is either any of them in 1 to 126, you can say that it is class A network, right? So if you look at class A network, we have observed that there are nearly 2 power 24 IP addresses in class A network, which means 16 million hosts. You can configure 16 million hosts. So generally who will buy this class A network is very big organizations like NASA, Pentagon, such things, right? But small organizations, they cannot afford to buy it. Therefore we go for class B. In class B, they know since it is very big, class A is very big, they solved it into class B. So let's see about what is the range and what are the other things of class B. Coming to class B, again we have the same thing. So one thing is in class B, how many IP addresses are present? 2 power 30 IP addresses are present, and all these 2 power 30 IP addresses have to be divided into networks and hosts, right? So whatever you want to play in class B, you have to play with only 2 power 30 numbers. So the question is, how many IP addresses are totally present in class B? It is 2 power 30, and then we are going to divide into networks and hosts, right? So first thing is, if I have a 32-bit number, class B always starts with 10, which means first 2 bits are fixed. You cannot do anything with the first 2 bits. They are already permanently fixed, right? And how they divided the 32 bits is, they divide into 16 bits of network ID and 16 bits of host ID. This is what they divided. Now with using 16 bits of network ID, okay, 16 bits of network ID we are going to use it. Already first 2 bits are fixed as 10. Then how many bits are remaining? The total number of bits remaining is 14. So how many networks are present in class B? It is 2 power 14, which is nearly equal to 16,000, right? Roughly equal to 16,000 networks. So in class B, number of networks is 16,000, which is 2 power 14. And if you buy any class B network, how many IP addresses you get is 2 power 16 IP addresses are present in one network, right? So totally there are 2 power 14 networks, and each network contains 2 power 16 IP addresses. Therefore total number of IP addresses is 2 power 30. That is what we have. We just divide into networks and hosts. Okay. And now I want to see the range. Just by looking at the first 8 bits, I want to find out what is the range of class B. I am not interested in looking at all the 16 bits or 32 bits. I want to see the first octet. So first octet is nothing but just the first 8 bits, right? So first 8 bits are nothing but 10 followed by 1, 2, 3, 4, 5, 6. So this is the first 8 bits, right? Now 10 followed by 6 bits, 0, 0, 0, 0. This is the first number. So what do you get? 128. So the weight of the first, if you have 8 bits and the first bit is 1, the weight of this is 2 power 7, which is nothing but 128. You can convert that binary numbers, okay? That I'll leave it to you as exercise. And the last one is 0. Next one is 0, 0, 0, 0, 0, 1, which is nothing but 129. And 0, 0, 0, 0, 1, 0, which is nothing but 130. So on. The last one is 1, 2, 3, 4, 5, 6. 6 ones. So 6 ones is nothing but 31. Already we have 128 as the weight of the first bit, and there are 6 bits here, so which is 31. So 128 plus 31, which is nothing but 1 second. 6 ones is not 31. 6 ones is 2 power 6 minus 1, which is 63. Therefore 128 plus 63 is 191. Therefore the last one is 191. You need not by heart this range, you can derive it this way. So the practical range of class B is 128 to 191. Now one interesting question is, if you look at the range of class B, you might get confused that I am showing only 128 to 191 numbers, so which is nothing but 64. I am showing you only 64 numbers, but then I am saying that there are nearly 16,000 networks. I am showing you 64 numbers and I am saying that there are 64,000 numbers. How is it possible is, we got only 64 numbers because we have examined only the first octet of 16 bits. There is one more octet, isn't it? The total network ID part of class B is 16 bits, but then I have shown you only 8 bits here. Using 8 bits I got 64 numbers, and how many bits are remaining? 8 more bits are remaining. Using 8 more bits, how many numbers do I get? Again one more 2 power 8. Therefore using first octet I got 64 numbers, and there is second octet remaining, for which I get 2 power 8 numbers. Therefore totally it is 2 power 14 numbers. 2 power 6 into 2 power 8, which is 2 power 14. So even though I am showing you only few numbers, 64 numbers here, they are capable of generating 16,000 networks. If you want to see how they could be generated, maybe you can observe this way. See this? So even though I am showing you only number 128, it is actually equivalent to 128.0, 128.1, 128.2, so on 128.255, which means every number is capable of generating 256 networks, right? We have 64 numbers and every number is capable of generating 256. Therefore total number of networks is 64 into 256, right? If you look at the next one, 129.0, 129.1, so on 129.255. What about the last one? The last one is 191.255. right? Therefore we have 2 power 14 IP addresses. Therefore we have 2 power 14 networks, and each network is containing 2 power 16 IP addresses are present in each network. Okay, so this is about the entire range, and if you have seen the range of class B is 128 to 191. See, the range of class A is 1 to 126. 0 is not used and 127 is not used. Why? We shall see it later. And coming to class B, the range is 128 to 191. Then you could guess what would be the range for class C. Since we are stopping here at 191, the next number is 192, right? Let's see that. Now let's come to this class C. In class C again we have the total number of IP addresses present in class C is, you can clearly see that the total number of IP addresses is 2 power 29 IP addresses are there. Now we are going to take this 2 power 29 IP addresses and we are going to divide it into networks and hosts, right? So how did they do it is, we have 32 bits, and in the 32 bits they are starting with 110, right? They divide it into 24 bits of network ID and 8 bits of host ID, right? So with 24 bits of network ID, already 3 bits are fixed. How many bits are remaining? 21 bits are remaining. Therefore, see, understand this, there are 24 bits of network ID, out of which 3 bits are already fixed. Therefore, how many bits are remaining? 21 bits are remaining. So the total number of networks of class C possible is 2 power 21, which is roughly equivalent to, I think, 2 million, right? Okay, number is not required, it is roughly equal to that number. And if you take any class C network, the number of IP addresses you get in any class C network is 2 power 8, while host ID part is 8 bits. Therefore, the number of IP addresses per one network is 2 power 8 IP addresses per network. If you buy one network, you are going to get this. What about the number of IP addresses in one network in class B? It is 16, 2 power 16, which is nothing but 64,000. So who are going to use this class B is, if you have banks like SBI or IRCTC, they are generally going for this class B. Now what about this class C? They are containing roughly 2 power 8 IP addresses, which is nothing but 256 IP addresses. So if you buy a class C network, you are going to get 256 IP addresses. Then who are going to use it is small offices and small colleges like engineering colleges, small universities. Generally engineering colleges, they don't buy any IP addresses like this, but initial use was in universities, they used to buy this class C. Now let's see the range of it just by looking at the first octet. In the first 8 bits, already first 3 bits were fixed as 110. Then how many bits are remaining? 5 bits. 1, 2, 3, 4, 5. Why? Out of 8 bits, 3 bits are fixed, and therefore we have 5 bits remaining. Then 0, 0, 0, 0, 0. Right? What is this? This is 128 and 64. Therefore, it is going to be 192. Right? And next one is 0, 0, 0, 0, 1. So it is going to be 193. So on 1, 2, 3, 4, 5. So this is going to be 5 ones. What is 5 ones? 5 ones is 31. Already you have 191, 192 as the first number, to which 5 ones are added. 5 ones means 31. Therefore the last number will be 192 plus 31, which is nothing but 223. Therefore the range is 192 to 223. So range of class C is how much? 192 to 223. Right? Now you should get a doubt. Doubt is, I am showing you only 32 numbers, but then I am telling you that there are nearly 2 power 21 networks. How is it possible? Same way, I have taken only first 8 bits of network ID, and actually there are 16 more bits remaining, right? Using first 8 bits I got 32. Using first 8 bits I got 32 numbers, and how many are remaining now? There are nearly 16 bits are remaining. Therefore we get 2 power this one, which is nothing but 2 power 21. 32 into 2 power 16, right? So if you want to see what they are, the IP addresses will be 192, I mean I'm talking about the networks, okay, 192.0.0, 192.0.1, so on, 192.0.255, and again 192.1.0, 192.1.1, so on, 192.255.255, which means one number actually represents 2 power 8 into 2 power 8, which is nothing but 2 power 16 numbers. So 32 into 2 power 16, which is nothing but 2 power 21. All the networks are possible. Okay, so this is about class C. Now coming to class D, let's see this class D here. So class A, class B and class C are actually used for the hosts, which means they divided the class A, class B and class D into class C into network ID part and host ID part. But coming to this class D and class E, they didn't divide it into network ID and host ID part. They have just left it like this, which means in class D and class E, we don't have anything called network ID and host ID. The entire IP address is left like this. So how many IP addresses are present in class D? It is nothing but 120, 2 power 28. And how many IP addresses are present in class C? It is nothing but 2 power 28. If you want to see the range of class D starts with 1110, and how many bits are remaining? 1, 2, 3, 4, which means 0, 0, 0, 0, right? And what is the last one? 1, 1, 1, 1. Therefore, the range of class D is 111 followed by all zeros is 224 plus 224 plus 4 ones is nothing but 15, 239. Therefore, the range of class D is 224 to 239. Okay, and the range of class E is, so you can guess, remaining 240 to 255, right? And these two networks are not used for the practical purposes of assigning IP addresses to hosts. They are generally used in class D is used for multicasting and class C is reserved. So the usage of class C is not known, and they say that they are generally using it for military applications. So if you see any range from 224 to 239 or 240 to 255, we are not going to use it. So this is all about all the networks, right? So one thing you have to note is, I am talking about how many IP addresses you will get if you buy one network of either class A or class B or class C. But then even if you have these many IP addresses, it doesn't mean that you can configure these many hosts. So whenever you buy any class, we are not going to use two IP addresses, the first one and the last one. Therefore, always the number of hosts that can be configured is two numbers less than the number of IP addresses present. In this case, even though you have number of IP addresses present as 16 million, which means 2 power 24, practically you cannot configure 2 power 24 hosts. You can only configure 2 power 24 minus 2. The reason we shall see later, I mean in the next video. The reason is this, I'll talk about unicasting and broadcasting next. And even here also, even though we have 2 power 16 IP addresses present in network, we are not going to have these many hosts. The number of hosts is going to be 2 power 16 minus 2. And here also, even though we have 256 IP addresses, the number of hosts we could configure is 254 only, right? So in the exam, if the question is how many IP addresses are possible, you go for these numbers. If the question is how many hosts are possible, you have to subtract minus 2. If the question is what is the total number of IP addresses, 2 power 31, 2 power 30, 2 power 29. How many networks? 126 here, why 2 are subtracted, and it is 2 power 14, 2 power 21. And what about D and D? We have only IP addresses there. How many IP addresses are there in class D? 2 power 28. How many IP addresses are there in class C? 2 power 28. Right, and these two are actually disadvantages of class full. The reason is 2 power 28. What is 2 power 28? Nearly 256 million. 256 million IP addresses have been reserved for multicasting, thinking that we are going to use this 256 million groups. But even today, from 1980s to even this day, we have less than 1000 groups, which means we are using less than 1000 numbers of this 256 million addresses which are reserved. That is why this class D is a disadvantage, right? And even class C, we don't know anything about class C, and it is, they say that it is for special purposes. And class D is completely wasted because we don't have these many groups. It is used for multicasting, which is for group emailing or group broadcasting, but we have only 1000 groups even though we have reserved 256 million. Now I'll show you why we are not going to use 2 IP addresses in every class, right, in the next example.